Hello, welcome to this video on binomial expansion, and up here you see this sort of how to sort of expand a bracket in the form a plus b to the power of n. And binomial expansion is a great help to us because say we have the bracket, say 1 plus x to the power of 6. Now this is equal to 1 plus x 1 plus x 1 plus x. I'm just going to write this out to prove a point. Now, if you was to sort of multiply all these brackets out, yep, it's manageable, but it would take a very long time. And this is this could be quite a standard question in a C2 paper, and you just haven't got the time to be writing it out like that. So binomial expansion sort of speeds up this process for us, and it uses a function on your calculator called NCR. You'll see it just above the division sign normally if you have a Casio calculator, and NCR relates to Pascal's triangle. Pascal's triangle is that triangle of numbers that was made famous by Pascal for uses in probability, but it also works in binomial expansion, and the NCR function relates to a certain number in a row and column of the triangle, and we can use it to expand brackets. So let's jump into an exam question. Let's say we were asked to find the first three terms of this series here, 1 plus x to the power of 6, in ascending order of x, ascending powers of x, sorry. That means, 1 plus x to the power of 6 equal to, now you start at n, and r just acts as a counter. Each time you add another part on, you add 1 to r. So r is 0, r is 1, r is 2, r is 3, and r carries on all the way to n. N stays constant here at the top of NCR, and what you're doing to each part inside the bracket is the a part, you're reducing the powers from n to 0, and b, you're increasing the power from 0 to n. So b tends towards n and a tends towards 0. A starts at n and b starts at 0. See, I should have put b there, but it's actually b to the power of 0, which is 1, so I left it out. And over here it would be a to the power of 0, which is 1, but I left that out. But we'll put it in here anyway. So we have 6c0 times 1 to the power of 6 times x to the power of 0. That's the first term. Plus 6c1 times 1 to the power of 5 times x to the power of 1, plus 6c2 times 1 to the power of 4 times x to the power of 2. Now as you'll notice, b has the same power as the counter r. Here 1 x to the power of 1, 2 x to the power of 2, and the difference between n and r, 6 minus 2 is 4, is the power of a, which is 4 here. Now to clean this up, 6c0, nc0 is always 1, so that's 1 times 1 to the power of 6, which is 1, plus x to the power of 0 times x to the power of 0, which is 1. So that's 1, plus 6c1, well, 6c1 is 6, nc1 is always n, just a tip there, 6c1 is 6, then you'd have 6 times 1 to the power of 5 times x to the power of 1. That would be 6x plus 6c2. Now 6c2 is equal to 15, and this means you have 15 times 1 to the power of 4 times x squared, which makes us 15x squared. And that's the first three terms in ascending powers of x. Now, just in case you're not sure how to deal with a negative, right? Say you have 1 minus x over 3 to the power of 10. Let's say we're just asked, say for time's sake, we're asked to just find the first two terms of this sequence. Now, you'd have to sort of rearrange this to 1 plus minus x over 3 to the power of 10. The opening up and bracketing of this equation is just to sort of clear it up and to sort of make sure you don't get the negatives mixed up with the positives, which will ruin your answers on certain powers. Now, this comes to 10c0 1 to the power of 10 times 1 to the power of 10 times minus x over 3 to the power of 0 plus 10c1 times 1 to the power of 9 times minus x over 3 to the power of 1, and then this equals 1 plus 10c1 is 10, 1 to the power of 9 is 1 times x minus x over 3, and this becomes minus 10x over 3. Next, in binomial expansion, you may be asked to sort of find a certain term of an expansion. Right, and say you're given, sometimes you're given sort of an equation 1 minus, let's say you're given 1 minus 4x to the power of 7, which would equal 1 plus, oh, what's happened there? 1 plus negative 4x power of 7, and you're asked to find the third term. Now, you know that 7c0 will be the first term. If you go back to here, nc0, nc1, nc2, blah blah blah, 7c0 will be the first term, 7c1 will be the second term, and 7c2 will be the third term. So you know it starts with 7c2. As I said before, the difference between the n and the r give you your the power which here a is raised to. So this means that 1 will be raised to the power of 7 minus 5, which is 2. 7 minus 2, which is 5, sorry. Can't read properly. And also, the power of b is always equal to this number here in each single term of an expansion. Therefore, you have minus 4x squared. Now, 7c2 is equal to 21 times 1 to the power of 5, which is 1, times minus 4x squared is equal to 16x squared. And then you end up with the third term equaling 336 x squared. That's the second type of question they can ask you. And lastly, they could also ask, say we have the expansion 2 plus x over 2 to the power of 9. They could ask for the term in x to the power of 5. Now, just because there's a 2 here doesn't actually change anything. You do the same as you would with the 1, you just raise it to the given power. Now, you'd get determine x to the power of 5. As I said before, this r bit down here, this bit down here is always equal to the power of b. And now, because x is on the right, x over 2 is b. So we need 9c5. 9c5 will give us some form of x to the power of 5. Because you raise x to the power 5, because that's what r is. And 9 minus 5 is 4, and the difference is what you raise a to. And in this case a is 2, so it's 2 to the power of 4. Now, 9c5 is equal to 126. Oh, 2 to the power of x over 2 to the power of 5 is equal to x to the power of 5 over 32. And 2 to the power of 4 is equal to 16. And this equals 63 x to the power of 5. And that is the term in x to the power of 5. And they're basically the types of questions you are most likely to be asked in a C2 paper. And that is binomial expansion for you.